chemistry time.
Hello and welcome back to Chemist Tea Time. As we continue discussions, it is important to focus on chemical reactions. In particular, we need to focus on reading chemical equations, balancing equations, and the different types of equations we may encounter. In our previous discussions, we have introduced several important chemical laws. Perhaps the most important of these laws is the law of conservation of mass, which states that matter cannot be created nor destroyed, it merely changes forms. This is specifically important when discussing chemical reactions because they express how bonds are broken and formed to allow for these chemical changes. We represent chemical reactions by writing chemical equations, which uses the chemical symbols to denote what occurs in the reaction and identifies your starting materials, which is known as your reactants, and what you produce are known as your products. When approaching a chemical equation, you read it from left to right, with your arrow designating what you are producing. Your reactants, which are located on the left-hand side of the arrow, are consumed during a reaction and form your products located on the right-hand side of the arrow. In addition to the chemical symbols, you also include in parentheses next to each reactant and product the physical state of each species denoted as G for gas, L for liquid, and S for solid. When you are dealing with chemical species that have been dissolved in water, you use the label AQ, which means aqueous. This brings up a very important point, which is the law of conservation mass. As we previously mentioned, this also applies to the chemical equation, and whenever you see chemical equations, you must balance the equation to ensure you have equal numbers of each kind of atoms on both sides of the arrow by using stoichiometric coefficients, which are the large numbers located to the left of the chemical formula. Let's take, for example, the reaction of hydrogen gas and oxygen gas to form liquid water. Keep in mind, both oxygen and hydrogen are diatomic gases. If we were to check this chemical equation to see if it was balanced, we would add up all the hydrogen atoms in the reactants, which is 2, and make sure this matches the number of hydrogen atoms in our products, which is also 2. If we do this for oxygen, we see that we have 2 oxygen atoms on the reactant side and 1 oxygen atom on the product side, which is not equal. Well, in order to balance the equation, I will show you how to do so using the algebraic way. If you follow this method, you will always end up with the correct answer. We will assign arbitrary coefficients to each chemical formula denoted as a variable starting with A and continuing on to C. Once we have assigned these variables to each chemical formula, we then assign the value 1 to one of the variables, and I find it best to assign this to either A or to the chemical species that is only located in one of the formula in the products. This will make more sense the more problems we work out. In this situation, A is equal to 1, and we can begin solving for the other variables by setting up a system of equations. We know the number of hydrogen atoms must be equal to the same number of hydrogen atoms on the right-hand side of the arrow, so we set them equal to one another. When we do this next step, you need to count how many atoms you have in each formula and multiply by the variable coefficient and set the equation equal to each other. For this example, for hydrogen, we would have 2A is equal to 2C. Keep in mind, we assigned A to be equal to 1, and when we solve for the variable C, this will end up be equaling to 1. Next, we have to make sure oxygen is also balanced. We have 2 oxygen atoms on the left-hand side, so this will be 2B is equal to 1C. We know C is equal to 1, and when we solve for the coefficient B, this is equal to 1/2. Keep in mind, you do not want fractions as your coefficients. So in order to get rid of the fractions, you need to multiply by the denominator. For this case, it is 2. By doing so, we end up with a balanced chemical equation of the following. Lastly, you always want to double check your chemical equation by making sure you have equal number of atoms on both sides of the arrow. We have 4 hydrogen atoms on the left and 4 on the right, and we have 2 oxygen atoms on the left and 2 on the right. Keep in mind to multiply the coefficient by the subscript to calculate the number of atoms. Let's take, for example, the following combustion reaction of C4H10 gas reacts with oxygen gas to form CO2 gas and water. Well, right off the bat, we can see this reaction is not balanced because we have 4 carbons on the left and 1 on the right. This tells us we need to balance our equation. Step 1, we need to assign our variables starting with A and going down the alphabet. Step 2, determine which variable will be assigned the value 1. Keeping in mind, you want to make sure you assign this to a chemical formula where the reactants are located only in one formula on the right-hand side if possible. In this example, A is equal to 1 because carbon is found only in one other formula, and so is hydrogen. Let's balance carbon first. We have 4A is equal to 1C. This is because we have 4 carbons on the left and 1 carbon on the right. We know A is equal to 1, and when we solve for the unknown variable, it ends up equaling 4. Next, we will balance hydrogen, and our equation will be 10A is equal to 2D. We know A is equal to 1, and we can solve for the unknown, and D is equal to 5. Last, we need to solve for oxygen. Keep in mind, we need to add up all the atoms that are the same. This equation will be 2B is equal to 2C plus 1D. The reason why we are adding is because oxygen is present in 2 different chemical formulas on the right-hand side, so we must add them. Keep in mind, we have already solved for the variable C and D, and all we need to do is plug those variables in and solve for B, which ends up equaling 13 over 2. Our last step is to remove fractions by multiplying by the denominator. Our final balance equation is 2C4H10 react with 13 oxygens to produce 8 carbon dioxide and 10 water. Make sure to watch the worked out examples for more practice on balancing equations. Continuing on with chemical reactions, we have different types of reactions that are commonly found, which are combination, decomposition, single and double replacement, and combustion reactions. When dealing with a combination reaction, this occurs when you have 2 reactants that combine to form a single product. Decomposition reactions occur when you have a single reactant that decomposes to form 2 or more products. Single replacement reactions occur when a compound reacts with an element, producing a new compound and an elemental product. Double replacement reactions occur when 2 compounds react and form 2 different compounds as products. We will discuss replacement reactions in more detail in later discussions. Lastly, a combustion reaction is when you have a substance that burns with oxygen to form gaseous carbon dioxide with water. As a review, today we focus on reading chemical equations, balancing equations, and the different types of equations we may encounter. As with other concepts, it is important that you practice and review these concepts in order to get more comfortable working with equations. Thank you for joining me and have a wonderful day. Thank you.
Chemistry time.